Hi, Denis. How are you today?
Hi, very well, thank you.
Excellent. Well, thanks everybody for tuning in. I just wanted to do a quick introduction. Denis Ignatovich, over to you.
Absolutely. So, co-founder, co-CEO of Imandra. Before that, head of a trading desk at Deutsche Bank. And Paul Brennan, I'll introduce you. Before Imandra, Goldman Sachs, head of the MTF, Sigma X. And prior to that, Rolls-Royce, aerospace engineering.
That's right. Okay, so Denis, it'd be good today to talk about a case study we have on our CodeLogician.dev website, our new product website for the CodeLogician tool. Do you want to say quick 2 lines about CodeLogician before we get into it?
Absolutely. So CodeLogician is one of our kind of interfaces for LLMs to get into the world of automated logical reasoning, especially it pertains to analysis of software and generation of software, aka vibe coding with LLMs. Obviously, these are very powerful, incredible technologies, but at the same time, they're risky, especially when you want to bring them into the domains of regulated entities, investment banks, exchanges, and so forth. So what today we'll talk to you about is how you can combine two types of AI. One is what LLMs bring, which is statistical, and one which is logical AI, aka automated reasoning or symbolic AI. And once you combine it, you start to have a process where you generate software and you mathematically verify it to meet certain criteria. And that is very much something that can be presented to, let's say, this process can be presented to compliance departments or regulators, so forth. Now, all of this is new for the world of finance, etc. But we're actually taking a lot of lessons from other safety critical industries that have relied upon tools like automated reasoning for quite some time. So even though this is all very new in finance, on this scale, very similar processes besides LLMs have existed in other safety critical industries where you have to make sure that things are safe.
Well, talking of regulated industries, here's the example I want to go through today. You remember in 2008, during the financial crisis, we saw all of the queues of people going outside of the bank branches trying to withdraw their money because they thought their bank was going to become insolvent. You remember that very well?
Very well. This is where control and making sure the logic is correct, etc. That's very paramount.
Yeah, exactly. So, in the US where you are, there's a federal deposit insurance company, and we have the financial services compensation scheme here. But the banks have to risk manage this stuff. And one of the processes the banks have to do is to identify accounts that might fall into that category of people trying to withdraw their money in the event of a liquidity crisis. So the case study that's on our website takes you through example process steps that can be used to identify these accounts. And what's really interesting with this procedure is it generates a lot of scenarios depending on the type of activity in the account, the classification of the account. Is it an active account, and does it hold cash? So there's quite a lot of things to take into account. And when people that work in these industries build such processes, they have to be demonstrably rigorous. Otherwise, if there's a hole in it, then that hole will be typically exposed at a point in time when you really don't want it to be. So
let me take a pause. I think this is also relevant to kind of broker dealers because you have very similar environments, especially when, let's say, there's an entity that's counterparty to everyone and it's going down. When can you shut off the access and things like this?
I'd just like to show you first the tools I've used to work through the example. Is that okay?
Absolutely.
All right, very quickly. We've worked with the Cursor integrated developer environment. So this Cursor has become very quickly a popular integrated developer environment, which is an AI native coding experience. So I've performed the coding in here using AI assistance. We've created a Python model that describes this procedure. I'm going to show you how I've integrated our Imandra tools to Cursor so we can do the type of analysis that we'll be talking about later. So this is our CodeLogician.dev website. We'll put the links in the notes below. CodeLogician.dev. Very easy for anybody to come here. There's tons of information available. Please do have a read through the docs you can see here. And there are also some case studies, and we're going to be working through one of the case studies down here, which is called bank account classification analysis, but I'll come back to that. I'm going to sign up for free. I've already logged in earlier today, so it recognizes me. And it takes us through to where you can select your free plan to get started, essential or growth. Now, since I'm already entitled to use in the Imandra Universe platform, I'm just going to go to the gallery and go straight to CodeLogician. What I want to do is integrate CodeLogician within Cursor, the AI native developer environment, so that when I want to analyze my Python code, Cursor knows how to do it. The way I'm going to go about that today, and there's a few other methods as well, you can have a look at the documentation. I'm going to follow the model context protocol. So this is really easy. I'm just being lazy here. I'm clicking on Add to Cursor. I've clicked on Add to Cursor. I'm just going to switch my screen share over to see what's happened in Cursor. So straight away, the cursor settings have popped up, and it's install MCP server for CodeLogician. So I would go through this process and click on install. If it asks you for API key in the screen I just previously showed you, you can click on there and it gives you your API key within your authenticated access. So you can take one of those, add it into Cursor, and you're ready to go. It's that simple. So shall we get started on the account classification procedure?
Absolutely.
Perfect. So I already had the requirements for this procedure, and what I did was fed those requirements into Cursor to start building the files that we created rather than sort of scrolling through the whole thing. This is the bank account classification tool. So we need to think about the data types that were created. So here we've got account classifications. We've got the classifications of different transactions. Periods such as start and end dates for looking back at different time windows. We've got other account classification attributes which are going to be used as part of our analysis later. There are other products as well, and each of them have eligibility sort of criteria as yes or no. That ultimately helps determine whether or not the account, what's defined as transactional or non-transactional. Transactional accounts are descoped from the risk analysis, but the non-transactional accounts, in other words, those ones that people hold their balances in, they're the ones at risk and need to be risk managed. To risk manage them, you need to identify them, hence this process. So we've got these transaction types down here. So what we're going to show you is, first of all, what does this process look like? And I'm going to use Imandra to enumerate and to identify all of the different pathways through this decision tree. And the reason I want to do that is to show you that it's easy. So I worked through this process in Cursor, and the process probably took me about as long as it would do to have written the product requirements to hand over to a developer to build the process. The process steps that Cursor helped me build are listed here, 1 through 6. So we check the sort of product eligibility, i.e. what is the type of account. We look at the types of transactions, we look at activity, and then we do some tests on the activity to see whether it was sufficiently active, and then we decide whether or not it was a transactional account. So we have this sort of decision tree here. Fairly straightforward, and what I'm able to do is now say to Cursor, ask Imandra CodeLogician to decompose using what we call region decomposition, decompose this logic tree into its different possible pathways. Why is that useful? Then I can test it. I can identify test cases to hit each and every possible pathway. Denis, when Imandra generates region decompositions over certain functions, what does that mean?
It means that it's considering all possible inputs and what the edge cases are. And really, when in the industry we talk about edge cases, kind of the mathematical definition of an edge case is a region of the state space. And the state space is just a collection of all possible inputs and current states of the system, so forth, like bank account balance. And when we're rigorously testing this stuff, we really want to make sure we're covering all of these edge cases. And once we transform this problem into domain of mathematical logic, we can actually do this without relying at all on statistics, and actually using the rules of logic to use all of these edge cases and understand what they are. And in ways that LLM just cannot, from the nature of how it is trained, the data is, and so forth. This is really where the combination of statistical AI, like LLMs, and logical AI shines, because you can combine these two both worlds, generate this formal model, rigorously analyze it, and then translate the results back.
So you can see the results on the screen here. Does that mean, if I tried really hard, I could find a different region or a test that would yield a different outcome from what we see on this screen?
Absolutely.
So Denis, these results on the screen from the region decomposition of that decision tree here that I had on the previous screen, that means Imandra's decomposed all of the possible pathways through that decision tree. If I tried really hard, could I find, say, a test case that falls outside of this list?
No. Now, what's special about this analysis is not necessarily that we have identified all concrete, let's say, instances or these edge cases. We have done that implicitly. But what's even more kind of stronger is now we have this logical argument. And this is what effectively, without going too deep into the technical details, we have a logical structure that describes all of the conditions when you effectively kind of fall into these edge cases. Now, the engine can construct concrete inputs that will push you in these different edge cases, can construct many of them. And those can be effective test cases or making sure that it's implemented correctly in whatever framework is being implemented. But the big outcome of this is we have transformed the problem from English prose, from kind of Python into mathematical logic. We have now these artifacts that we can ship off to a regulator to demonstrate that this is actually logically sound. And then for all of these different edge cases, we can produce concrete input vectors, which then can be translated into Python, Java, C++ languages. But this process gives you this framework where you can say, hey, we use web coding, but it's done in a controlled environment.
Wow.
So it's object of someone's, let's say, lack of or like ambitious prompting or, something else that's qualitative. This is actually a quantitative framework for controlled application of these techniques.
Let me say that back to you. We can prove that this list of all 19 rows is a complete set. That's a full representation of the model that we made. So everything above fits into one of these rows. There's no way of finding a different region. This is full. This is complete. And then the other point you said there was quite interesting. Let's zoom in on region 0, checking account. Imandra can synthesize many different actual test cases that would fit into that category, so people could test their systems.
Absolutely.
And you could repeat that for each and every one of those 0 through 18 regions. Wow. So what we then did with this model is you said, well, hang on a minute, we don't really care about bank accounts that have got tiny balances because, if people withdraw it, the impact on the liquidity of the bank will be de minimis. So what we said was, well, let's extend this procedure and have a balance check to see if the cash balance held in that account is sufficiently large. So all we've done is performed a simple extension of the code by adding this and balance check. And we're saying, is the balance less than $25 million in this case? So it's just a couple of extra process steps. I've shared on this screen left versus right, old versus new, and you can see that for a simple additional check, we have a couple of extra steps. Didn't take long, and it was a sensible addition. But what we then did was ask through Cursor Imandra to perform the region decomposition one more time. Any ideas what happened?
Let's give it a try.
Wow. Okay, so it was previously 0 through 18. Now it's 0 through 54. I think that's like 190% increase. So I compared my time spent on this earlier to, as a product manager once upon a time writing the spec. That was writing the spec, but it would have taken me ages to write those 19 example tests if I was successful in identifying all 19. I think we've got to the point here that through the click of a button, Imandra has generated this 55 different regions, and it hasn't cost me that sort of exponential amount of time in figuring out what all of these different combinations are.
Now, Paul, let me ask you this. If you are sitting in a bank and you're wipe coding, and let's say you have this explosion, it went from one number to a much bigger number.
Yes.
And if you don't have Imandra in the mix, do you just stand up and say, wow, this is great. Okay, let's put it in prod and hope for the best and see where this takes us? Or do you get nervous and think, okay, maybe I don't want to gamble with this, my career on, some guy in Silicon Valley training the LLM, and maybe I need to go through this myself.
I think what happens in reality is things slow down, deadlines get missed, and costs go up.
What about, let's say, nervousness of the management in the overall approach of using LLMs if they see results? Does that increase or decrease?
I think nervousness generally increases, especially from what I see. What we can make the claim here with is that whilst we are seeking those productivity and efficiency gains, the Imandra complement to the process counterbalances the risk management issues. This doesn't supersede the need for quality governance, procedure, training, skill, domain expertise. If I wasn't a domain expert on some of these examples that we write and we talk about, it would still be dangerous. But in the right hands, this is a very powerful tool. Denis, how scalable is this?
Very scalable. In fact, with this process, we have modeled some of the world's largest financial infrastructure components, responsible for significant percentage of trading activity in developed markets, and really complexity that is beyond any single human's capacity to understand when it comes to all the edge cases, and most certainly very exposed for hallucination when it comes to LLMs.
Wow. Well, I think this slide here wraps it up. Simple code artifact there on the left, slight change in requirements. That happens all the time in the real world. We see a 190% increase in behaviors, but we can give people 100% certainty that we capture those increase in behaviors. I think that covers today's talk. Thank you, Denis, for joining me.
Absolutely. My pleasure.
See you next time.
See you.